Dear colleagues, I'm delighted to introduce Professor John Carroll, who is also head of the Department of Informatics at the University of Sussex. Probably the key words for what Professor Carroll is doing are intelligent and robust. The natural language processing group at the University of Sussex is designing methods for intelligent natural language parsing, intelligent extraction of sentiments from natural language text. And Professor John Carroll is very well known and top professional in natural language processing and parsing techniques, and many projects are wide known all over the world. And Professor Carroll has been chairing many events very important in the area of natural language processing, such as the 45th ACL conference at Prague, where Professor Carroll was the general chair for the whole event, very big event, tremendous actually. And still, Professor John Carroll is the author of the last parsing system, and then a topic of today's talk is concerned with sentiment analysis and intelligent methods for sentiment analysis of natural language text. But it is one of the directions of very profound and advanced research connected with natural language processing, which are headed by Professor Carroll and carried out by Professor Carroll and his natural language processing group, and as well as colleagues all over the world, as Professor Carroll is a secretary for the special interest group in natural language parsing. And the results of the research and development efforts of this group are very important, I should say, for the state of the art, for the research and the whole community of natural language processing. So I give word to Professor John Carroll.
Thank you so much for inviting me to give this talk here. I'm very privileged. It's my first visit to Russia as well, so I'm very pleased about that as well, and seeing your beautiful country. Okay, so, and thank you very much for that introduction. So this is not just my own work, it's particularly the work of three students or collaborators of mine. Jonathan Reed, who's a past student of mine, did his PhD in sentiment analysis. Similarly, Taras Sagovalov, who's from Siberia, so I'm very pleased to be presenting his work here. And he had, in his turn, he had a student at Siberian Federal University, Katerina Belyatskaya, I think. And she's done some interesting work on analysing sentiment in Russian, how it's expressed in Russian. So there's some of her work in here. And a student or a postdoc from Japan, Danushka Bologala, who I've been collaborating with, and my colleague David Weir at Sussex. So I have to thank them. Okay, so the outline of my talk is I'll give a motivation, brief introduction to sentiment analysis, although it's quite a well-known task nowadays. But I want to point out a few methodological issues with what's going on in the field at the moment, and that motivates the approaches that I'm going to be describing in the rest of the talk. There are three different approaches, all of which I would characterize as being robust, in that they make relatively little use of training data. So they are data-driven, they're machine learning approaches, basically, but unsupervised or weakly supervised or semi-supervised, not fully supervised machine learning. And then I'll conclude, and hopefully we will have time for questions and discussion at the end. So sentiment analysis is a subtask of the more general topic of opinion mining. So I've listed here quite a few other aspects of opinion mining which go beyond sentiment analysis, and sentiment analysis is generally thought of as really just classifying a document as a whole according to the tone of its author or the sentiment of its author with regard to the main topic that they're discussing. So the standard example of that is product reviews or reviews of plays or books. So does the person who's been using the product or has read the book or seen the film or the play, do they view that positively or negatively? So usually it's just a two-class problem, positive or negative. But there's also other subtasks, other types of tasks to do with opinion. So subjectivity is something couched in subjective or objective language. So is there opinion in there in the first place? Sentiment classification or polarity. Relevance to a given topic. So is this document talking about something that we're interested in a way that we want to actually get the opinion out of? Authority or influence. So does this person really know about what they're talking about? That's important, obviously. And who is the opinion holder, or who is reported as holding an opinion about what? So that's opinion holder and target identification, and lots of other sort of facets of opinion mining. So sentiment analysis is part of quite a wide-ranging and diverse set of tasks. But in this talk, I'll only be looking at the sentiment analysis aspect of opinion mining. Oh, and I should say, there's a play on words here. So I kind of characterise opinion mining as a natural language-based task. It's both natural language processing based, and it's a natural task in that it's something that people commonly do. They want to know what other people think. So it's natural language processing and natural language processing. Okay, so it's an interesting research area, and it's also of great commercial interest as well. There's lots of money in this area. And that motivates some approaches to this work, and there are a lot, particularly in the USA, there have been a lot of startup companies that have been developing and trying to sell sentiment analysis technology. Why is it important, or why is it commercially important? Well, organisations, or companies, or political parties, or social organisations generally want to know how they're viewed by the media. So what are the newspapers saying? What are bloggers saying about them? What do business analysts say about a company? That can affect share prices or perceived brand value. What customers think about the products of a company, and even what do employees of that company think about the company. So some companies monitor internal emails and try and work out whether employees are viewing them favourably. Or if there are questionnaires, internal questionnaires within a company, you could think about analysing those questionnaires automatically. And people, ordinary people, want to know what other people think about products, about services and entertainment, so books and films, and about stocks and shares and other things, political viewpoints as well, so on blogs and online forums and so on. So in fact, I came into this area through the commercial route. So there was a local company that I had some sort of shared contacts with. I had mutual friends who were working in this company, and they said, we've got a contract, can you help us with this contract? And that company was originally called Algorithmics, got taken over by Inphonic, which in turn got taken over by Corpora PLC, and none of those exist anymore. So this was quite a while ago. This was about 8 years ago. So this is just to remind me to talk a little bit later about one of those experiences, one of those commercial experiences with the company Corpora. And I've also recently been involved with a local company in Brighton, where the University of Sussex is located, called Brandwatch, and I'll say something about Brandwatch at the relevant point of the talk as well. So two commercial interests in here, as well as this being a really interesting research topic that I and my students have worked on. So in the past, opinion analysis was carried out by teams of humans, often by cutting out bits of newspaper, gluing them in a scrapbook, reading them and summarising them, writing reports. So everything done manually with paper and scissors and glue. Really. This isn't the case anymore, or generally not the case anymore. A lot of it's, or almost all of it's being computerised with respect to gathering information, but analysing the information is still often done by humans. And the motivation, of course, is for natural language processing people to work out how they can replace those humans or to allow them to do a better job. Information may come from many different kinds of documents, such as product reviews, newspaper editorials. Newspaper editorials, well-written, nicely written text, carefully honed. Blog posts, often not very carefully written, or Twitter, so other social media where it's usually not very well written at all. So there's a wide variety of text types, which is also interesting as a language processing problem. Okay, so why is this a difficult and why is it an interesting task? Well, sentiment can be expressed in a multitude of different ways, with subtle shadings as well. So linguists amongst you will think of many other different ways in which opinion can be conveyed in a very implicit way, not in any explicit way. So these are two contrasting reviews containing the phrase, I just want to look at the phrase particularly, a heavy read. So that usually implies that it's heavy going, difficult to read, not enjoying very much. Whereas this review says this is a weighty tone, and if it's a reference book, being weighty is really good. And tome is an archaic word for a very thick book like the Encyclopedia Britannica or something like that. So this is positive. Weighty tone, particularly in the context of a reference book, is good. And essentially those mean very similar things, but the extensional meaning is very, very similar, but in terms of sentiment, they're expressing exactly opposite things. Different expressions are used in different domains or text types, or even over time periods, and I'll talk about that in a moment. But here's an example on the left here of the type of review that you typically get for books. So you use words like excellent, broad survey, high quality, interesting, well researched, also disappointed if it's a book that you thought would have been better than it actually was. And on the right here we have words that, or types of reviews of kitchen appliances. So this one's about a food processor. They were thrilled when they unpacked it. It's high quality and professional. This grill is energy saving. So you'd never have a book described as energy saving, but you would a kitchen appliance. That's good for kitchen appliances, just not relevant for books. Delicious, books are never delicious. Well, not really. But if you're making good food with a kitchen appliance, then it's probably a good kitchen appliance. Rust, books don't rust, but kitchen appliances do. But you can also be disappointed, so you can be disappointed with both types of product. So there's quite a diversity and diference in types of expressions you get. And even the same word can mean opposite, complete, or denote complete opposite opinions in different domains. So the film's plot is unpredictable. We normally like unpredictable films. We don't like conventional ones which wouldn't be surprising. We want an element of surprise, so that's good. But the cast theory is unpredictable. That's quite bad. We don't want to crash. So words, even with the same meaning, have different sentiment denotations. And So I've been talking about lexical means, so words. Sentiment can also be expressed by phonetic or orthographic means. So here's an example here. We've used capital letters and spelling out the syllables of the word, bologna, in a Russian review here. I don't know much Russian, but apparently this is what this means. Is this podolki? Yeah. So this is used as well. Slang, again, it's orthographic rather than actual lexical. And there's also expressions at the syntactic and sentence level, again not lexical. So what did the author eat / drink / sniff to write stuff like that? So this is a rhetorical question, and it's not actually a question, it's a negative way of saying that the author has drunk or eaten or sniffed something strange. And read everyone, so it is an imperative. So this is, again, not a straightforward way of expressing the feeling. And there are many other ways, so I can give a reference at the end to other things that we've looked at, including topic shift, so starting to talk about one thing, ending up talking about another that's related, and the opinion is somewhere between the two of them. An example of that is reviewing film. So you might talk a lot about the plot, and then talk about why you like the film. So you have a topic, which is what the film is about, and then your opinion, which is what you think. And the two might be quite divergent, so the film might be very bloodthirsty, lots of people die, but you still like it. So death is usually bad, but you might still like the film. And there are other sort of difficulties to do with the language which make sentiment analysis quite a difficult task. Okay, so the standard sort of paradigmatic machine learning approach, supervised machine learning approach, is to take a set of documents and a set of classification for each of those documents, which might be a star rating, perhaps on a review site. So for each document you have whether it's positive or negative. You automatically extract a set of features from the documents, and the features are standardly words or word n-grams, so sequences of words that occur frequently. And then your machine learning algorithm, which might be naive Bayes or support vector machines or something like that, would learn weights on those features which correlate with the classification. So then you'd run on documents that you didn't have a classification for, you'd extract features automatically, run the machine learning algorithm which has learned weights for those features, positive or negative weights, and it would tell you, the machine learning algorithm would tell you whether this document is positive or negative according to those features and the weights it's learned. So a standard way of doing it, as I mentioned, is support vector machines, and technically, roughly what that does is transform the set of feature vectors, so the feature vectors for each of the documents, into a space where you've only got positive feature vectors on one side and negative on the other of a hyperplane which separates them. So if you end up with something down here, it's going to be classified as negative, something up here as positive. If you do that, you get good results if you run on very similar data to the data that you trained on. So if you trained on book reviews and you test on book reviews, normally you get quite good accuracies in the 80% region, perhaps more. What my student Jonathan Reed noticed was that if you don't do that, then the accuracy really degrades. If you train on one type of text or one domain or one topic or even one time period of a set of documents in a single domain, then you get and test on another, so run on unseen data from another domain or topic or time period, the accuracy really degrades. So looking here at topics, we've got documents from the topic of finance, from mergers and acquisitions or a mixed set of documents in both of those domains. This is all newswire text, so it's all text of the same type. It's just the topic, quite a fine distinction between finance and mergers and acquisitions, so companies taking over other companies. If you train and test on the same topic, you get the figures down this main diagonal, so you get the best figures. You get quite large decreases in accuracy if you use a different training set than the one you're testing on. So perhaps down from 81% to 69%, so a big decrease in accuracy. A similar thing goes for domains. So we're looking at here at Newswire, and so what journalists are writing in a newspaper, compared with what people are writing on a movie review site. So polarity is the Pang and Lee data set on what movie reviews. And again, the very big, even bigger decreases in accuracy, I think also partly because it's a different genre. And even time periods. So this polarity one is the Pang and Lee data from before 2004. Jonathan collected a matching data set from the year 2004 and did a comparison, and you'll see that accuracy drops 3 or 4% just over the course of a couple of years of exactly the same data, or almost exactly the same data, because people are talking about different films in different sorts of ways. So there's a big dependency, and this is a problem with supervised machine learning approaches in this area. Another disadvantage is that, well, the one that follows on from that is that you really have to annotate new data in your new topic area, or for your new language, or your new domain, or your new time period, to get the best results. So supervised machine learning techniques don't scale well, or you have to do a lot of work, a lot of manual work to use them, which really almost defeats the purpose of machine learning, which is an automatic method. So in my lab, we've been looking at techniques for unsupervised, or weakly supervised, or semi-supervised machine learning, learning from data, such that we don't have to do a lot of manual work when we're moving between domains or languages or topics or time periods. So I'll be talking about those in a minute. I just want to mention a few standard data sets that we've used that I think are well worth the community using as standards, and some of them are really well-established standards at the moment. So the Pang et al. Movie reviews, that's been very widely used. For cross-domain sentiment analysis, so for training or developing a system in one domain to be applied in another domain, the Glitzer or Mark Dredsey, Amazon reviews is a very good data set. And then in Chinese, Japanese, and English, there's the NTCIR test sets, and we've used some of those. We took part in NTCIR's IR7. And of course, here we're going to hear a little bit later about the sentiment analysis track in Russian. We've also, because these don't cover all the languages and types of text we're interested in, we've had to scrape the web for some kinds of data. So particularly for book reviews, from newspapers, we've done that, scrape the web for those, and also for data in Chinese, so quite large amount of data in Chinese, and Russian as well, we've scraped the web. So I'll talk about those data sets when at the relevant time. Okay, so I want to look at 3 systems or 3 approaches that we've experimented with fairly briefly. So I have about 3 slides or so on each. And the first approach we call weakly supervised, and it draws on the work of Peter Turney. So he published a very nice paper in 2002, which looked at using point-wise mutual information of the words good and excellent and poor with all the words in the document, and if you had a preponderance of words which were more similar to excellent, then the document was classified as positive. If more of the words were similar to poor, then the document was classified as negative. To be able to use this technique, you need a very large corpus, very large background corpus, to be able to find the similarity of as many words as possible in the language to excellent, and conversely then also to poor as well. So we reproduced some of those experiments, and essentially this equation summarizes or explains precisely what I just said. That we're looking for similarity of every word in a document to one of excellent or poor, or to one of the sort of paradigmatic words in our class. And if more of those occur with, or are similar to a positive word, then the document is positive. If more of them are similar to a negative word, then the document is negative. But what we do, and what seems to work better, is to have several prototypes per class. So not just excellent and poor, but several words meaning good, and several words meaning bad. So the way we did that was semi-automatically, well, a very light manual process of retrieving synonyms of the class labels, so synonyms of positive, synonyms of negative in WordNet. No, sorry, in Roger's Thesaurus we could have done it in WordNet or any one of these types of resources. Filter out those which are ambiguous, so could mean something else unrelated, and retain only the end most frequently occurring. We've got prototypes here: benefit, best, excellent, good, nice, perfect, supreme, and abuse, bad, disastrous, evil, outrage, sad, and wrong, and use those instead of excellent and poor, and got better results than internally. Also, what we did, Tony's approach just used first-order similarity. So is a word, from our large background corpus, does the word occur near excellent or poor? So that's using pointwise mutual information. We also looked at second-order similarity. So is the word semantically related to either excellent or poor? And we had a very nice talk this morning which talked about semantic similarity, looking at context vectors, and we just take the cosine between context vectors as a way of measuring semantic similarity, or do these two words occur in similar contexts. So our results, we compared them with the standard supervised machine learning setup, and this is looking at different topics, different domains, different time periods, so the types of data that I talked about a few minutes ago. And looking at what happens sort of to a supervised approach, where you train and test on the two different types or on the same type. So this is with, I think, 3 topics. So this is the average of 9 different points, so 3 times 3. That's the average of 4. And that's the average of 4 accuracies, training and testing on the different combinations of data sets. So supervised machine learning gets these average accuracies. For the lexical association similarity, we get slightly lower accuracies. So similarly for semantic spaces, which is using second-order similarity. But one thing to note is that although supervised machine learning does better, and I was a little bit disappointed that it did, but our unsupervised or weakly supervised approach is much less variable. So I've given the standard deviations of the accuracy scores. And you can see that supervised machine learning has a standard deviation of 9.6 percentage points. So very wide divergence between the accuracies, between the 4 experimental setups. whereas the weakly supervised has much lower. So it's much lower standard deviation, so it's more predictable what's going to happen, which in some types of application could be a useful property. That technique doesn't just apply to sentiment analysis, so we've also looked at other effective text tasks. So you can classify effect differently, not just positive or negative, but into other types of categories: so anger, disgust, fear, joy, sadness, surprise. And we can use exactly the same technique to find sets of words which are anger words, disgust words, fear words, joy words, sadness words, surprise words, and we get these lists using this very light manual approach, and then we can use exactly the same PMI or semantic space method to classify documents according to whether they're predominantly angry or not angry, if the person shows disgust or doesn't, if they're showing fear or not. So we took part in the Semival 2007 effective text task and did reasonably well in that. Also, what we've done is look at a linguistic framework called appraisal theory by James Martin and others. So this is in the area of what's it called? Systemic functional linguistics. And there's a very large taxonomy of types of effect that can be exhibited by an author of a document. So we've looked at those and done similar things with that linguistic framework as well. And probably that's the largest computational investigation of appraisal theory. And I can give references to that if anyone's interested. Okay, so that was weakly supervised learning. As I said, slightly disappointing results, but interesting in the fact that it was only, say 3% worse than supervised machine learning, but also much more predictable what results you were going to get. The second approach I want to talk to you about is a less supervised, so it's unsupervised or perhaps almost unsupervised approach to sentiment analysis. We've done most of the work, most of the experimentation on Chinese. There wasn't a good Chinese sentiment analysis corpus before we started, so Taras Agavalov scraped the web for Chinese reviews from the website IT168. And he created 10 balanced labeled subcorpora covering product reviews from ordinary people talking about computer monitors and mobile phones, digital cameras, and so on. So here's an example of a review. Don't ask me about Chinese, I know nothing about it, but he tells me that this is a translation of it. So the response time of this mobile is very long, MMS have to be less than 30 KB to be downloaded, also it doesn't support MP3 ringtones, and so on. So this is a negative review written by this Chinese citizen. So the way we go about applying our unsupervised technique is just to start with a single word, just the single word good. So good is pretty unambiguous, and this Chinese character is apparently fairly unambiguous. And of course, good occurs more often in positive texts than negative texts. And it turns out it appears more frequently without negation than with it, which is quite fortunate as well. So what we do is identify a set of seed lexical items with the same behaviour as good, that follow the same pattern or same distributional pattern as good. We only need a small number of those because what we want to do is to produce a high precision classifier, so something which, when it does make a decision, a classifier for sentiment, when it does make a decision, it's almost always right, but it has low coverage to begin with. So there's a couple of minor tweaks that we have to do that, but to get that to work. But when we do that, and we do that for each domain separately. So for each set of reviews for computer monitors, we do apply this technique. For mobile phones, we do it again separately. For computer peripherals, we do it separately. And we get, interestingly, we get different sets of seed terms, different sets of words which pattern similarly to good. So for computer monitors, we get words, these are the top seeds for computer monitors: good, convenient, cheap, clear, straight, comfortable, fulfilled, sharp, comfortable, cool. So these are words which appear frequently in positive reviews of computer monitors, as found completely automatically, just starting with knowing that good is good, basically. For mobile phones, if we do the same thing on those reviews, we get some of the same words, so good obviously, convenient, cheap, clear, comfortable, and another way of saying comfortable. We also get other things which obviously are more applicable to a good mobile phone than a good computer monitor, like durable. You often drop a mobile phone, but if you drop a computer monitor, you don't really expect it to survive. Distinctive, that's good for mobile phones. Smooth and easy operation, I guess. User-friendly, easy to use. Good support, because they're more complicated to use than monitors. So we get a sort of customized list of positive words for each domain. And then, as I said, we produce a high precision, low coverage classifier for each domain. And then we bootstrap that classifier by applying it, finding reviews which it thinks with high reliability are good, and taking the most frequent or most distinctive words from those, and adding them to a list of words which should appear in good reviews, and conversely in bad reviews. So we classify, learn to distinguish in vocabulary, add that to our classifier, retrain and classify again. So this is a cyclic process which we run it until it converges, which is usually around 15 to 20 iterations. And what sort of results do we get? Pretty good, actually. We were very pleased to get these. And we, again, compared with supervised machine learning on these domains separately. So each domain was classified as a separate set of data. With supervised machine learning, we use cross-validation to do that. And for most of the domains, our unsupervised or almost unsupervised approach did better for accuracy. So for 7 of the domains it was better, for 3 it was worse, and overall it was better. I think one aspect that accounts for this is that there was relatively little data for the supervised approach to actually train from, even with cross-validation. But that's usually the case in practice. Usually you don't have as much data as you could possibly want. Usually data is limited, particularly if it's annotated data, which is what's needed for supervised machine learning. Okay, so that was the second thing that we've been experimenting with. The third thing is more recent, and this is work with, between myself, David Weir, and Dennis Kërrolli. And what we're doing here is extending some recent work in semi-supervised learning. So people usually describe, or the label semi-supervised learning is applied to a way of learning from annotated data, a limited amount of annotated data or labeled data, and a much larger set of unannotated data, which is what usually happens in the real world. You only get some manually or linguistically annotated data, but you've got a large amount of raw data that's also relevant, and you want to extract knowledge from that and use that to improve your performance. So in sentiment analysis, how it works is that there's a set of labeled data for a source domain, So this might be reviews of kitchen appliances, perhaps, but only unlabelled data for a target domain. So that might be books, for instance. And you also have potentially a large amount of unlabelled data for the source domain as well, which you can use. So the way we want to take advantage of this is to use this large amount of unlabelled data to look for words which are similar to words that we know about, words that we know are positive and negative, because they occur in positive and negative reviews. And also to take better advantage of the fact that words occur in positive and negative reviews by actually labelling those words implicitly as positive or negative words, not just by virtue of the fact that they're features in a machine learning setup where they occur in positive and negative documents. So just to make that a bit clearer, so if we have the word excellent and broad survey and the development of civilization, that probably comes from a book review, and if that's probably in a positive review. We part a speech tag that. We get lexical elements, which are the words and bigrams, and we also get what we call sentiment features, which are those words and bigrams labelled with whether they occur in a positive or negative document. So we get excellent star P, broad star P, excellent plus broad star P, and the star P means that these occurred in a positive document. We also have star N if a word or bigram occurs in a negative document. And then what we do, and I'll skip over this because it's too technical, I think, for the time I have available, is to create a sentiment-sensitive thesaurus. So what we want to do is to gather together all words which mean similar things and which also have similar sentiment, either positive or negative sentiment associated with them because they occur in positive or negative documents. So we want to create a set of entries, and here's an example one of professional. Professional co-occurs with words which also co-occur with excellent and invaluable resource and definite by. Well, if that's the case, then we get a thesaurus entry for professional like this, where we have excellent, invaluable resource, and definite by as neighbours, or as very similar, as being very similar to professional and similar to each other. So we've got these thesaurus entries, so we gather together words which mean very similar things, both in terms of meaning, probably, but also in terms of sentiment, that they have similar sentiments. And then what we do is use these to train a machine learning classifier on our source labelled domain, on our source labelled data, but also throwing in this information from the thesaurus of words which mean similar things. And that gives us greater coverage and also greater precision because we're taking into account more information about sentiment. So, for example, if we have the word excellent in a review, excellent would be one of our machine learning features. So we get a count, the number of times excellent occurs in that document. Sorry, this is at the bottom, so it's a bit difficult to read. So we get, in our vector, representing the document, we get a count for excellent. And we also get some contribution from professional as well, because professional is excellent is in the entry for a professional. As long as there are enough other words which allow professional to come in, so enough other words that are similar as to professional as well as excellent. And then we train up a classifier, and we can learn on one source domain and use additional information, unlabeled information from that source domain, and also from our target domain. So we bundle all that together and create a thesaurus each time we train up the classifier. And this graph indicates that if we just train on single domains and test on another domain, we don't get such good results as if we train on combinations of 2 or even all 3 domains, while of course keeping the amount of training data the same. So just sampling 3 domains rather than all of those 3 domains. So we're on a level playing field. And I think this is a very interesting result which indicates that we think we're getting more robustness from training on several domains rather than just one domain, because we're getting better accuracy. So this accuracy is going up from around 70% to 84% by training on several domains. And this is a comparison with a baseline and an upper bound to show that firstly we're a long way above the baseline, quite near the upper bound, and we're doing a lot better than many other systems in the past that have been described that use semi-supervised machine learning. We're doing it a slightly different way, so that's why we're better. So this is our approach, and we're in the 80s, or almost in the 80s, except for when we test on books, and then some other approaches do better than us. And we're not quite sure why this is. It might be a wider range of expression in the books domain, but we need to analyse that. So one thing to look at particularly is this baseline, which is just supervised machine learning without any domain adaptation, so not doing semi-supervised, just using supervised. And that's comparatively low results, so that motivates the use of semi-supervised. We're a long way above that. We took out the sentiment-related features from our technique and just did everything else the same, and we got lower accuracy, so those star P's and star N's on the features are contributing a significant amount of extra information. So that was a flavour of the third technique that we've been investigating. So I've talked about 3 different kinds of approaches which I've argued are more robust than the normal supervised machine learning approach to sentiment analysis, because they're either more predictable or they give better results when you train on one set of data and test on another. So you talked about bootstrapping, automatic thesaurus creation, expansion of bag of words representations, and there's lots more stuff to explore in this area, I think. But a couple of issues that we might want to follow up in discussion I think are particularly interesting are, is it possible to incorporate further linguistic insights into these techniques? So really I've just been talking about lexical means of expression of sentiment, but I mentioned near the beginning that there's sentence level, phonetic, orthographic, issues to do with topic shift, other ways of expressing sentiment which require even world knowledge. So there's a review that I saw which ended with the word chiffre pastel, and that's referring to reboot on Windows. So that's obviously a bad review, and that requires all sorts of extra knowledge that it would be great to get into the computer. And are there better ways to improve the portability of language technologies across domains, genres, and so on? So I talked about semi-supervised learning, and I think there's a lot more interesting research to be done in that area. So I would encourage anyone who's interested in this to have a go. And I'll leave up references so you can note them down if you're interested during question time. So that's it. Thank you.
Thank you, John, for the talk. My question is, it happen during the bootstrapping that you actually pick the words that caught you with, say, positive set of words, but themselves the words are not positive? For example, if you have a movie review, and then you have lots of movie reviews about, let's say, the movie Avatar, and then you have the name of the movie Avatar, which is decided by the bootstrapping that it's positive, but then when you have to actually review, negative review about the Avatar, then it will be misclassified.
Yes. It's a very interesting question. We didn't actually look at it with respect to that set of experiments, but we noticed in the first, well, Jonathan Reed noticed that there are particular words that occur in movie reviews for movies that most people like, that if perhaps later a lot of people didn't like it, then that might affect the accuracy. So the phrase ice axe, there's a film, Touching the Void, which is about someone falling into mountaineering, falling into a crevasse, almost dying, and then getting out because he could use an ice axe, so effectively climbed out and almost died, but just made it back to base camp. And lots of people liked that film, and that's and as a result, ice axe got a very high positive score, as we saw in our set of features. It's very difficult to avoid that sort of thing, and I think that might be part of what's behind the time or the temporal dependence of sentiment analysis. So if a later film was also about mountaineering and most people didn't like it, then that would probably get misclassified, because if ice axe was in, if someone was using ice axe also in that film, then the data would be wrong. So yeah, it's a good question. I don't really know an answer to that. Thank you.
Are you including the negations part of your features?
So the question is, am I including negations as features? And no, I wasn't. And it's quite strange that with these machine learning type approaches, it doesn't really seem to matter that much. What I think they're relying on is redundancy, so that if every review depended crucially on whether negation was there or not, or if a review used negation everywhere, then it would probably be misclassified. But there are usually enough words or phrases in there which don't have anything to do with negation, which allow the classifier to actually function correctly. But that's an aspect that it would be great to get in, to actually have a good analysis of negation, and also sort of other hedging phenomena. So I might have liked this film if it were not for the fact that, things like that. And if we could analyse those correctly, then that would be fantastic. But we'd also be well on the way to full natural language understanding. We know how difficult that is.
Thank you for your lecture. I'm interested whether you have taken into account, sorry, it would be better without the mic. Well, I'm interested whether different results for different groups of Amazon reviews, say kitchen appliances, books, mobile phones, classical music, and so on, might be due not to the features of these domains as such, but to the fact that there are different customer communities which may use different sets of negative and positive classifiers.
Yes, I think people definitely do write differently. So usually book reviews are written by more educated people, because you don't read a book if you're not very educated, usually. We also collected a set of book reviews from The Guardian newspaper, which is a high-quality newspaper in the UK. And we did that because the use of language was very, very sophisticated in that. And we wanted to test out appraisal theory, because that expresses you can encode private states of the person as well as public states. It's a very refined framework. So certainly there are very different types of writing across all of those, and I mentioned Twitter as well, as it's something else that we're looking at in my group. David Weir's leading on that, and there he's trying to classify tweets that people send out in response to an audience participation program where they vote for the best act, the best singer, and usually the language there isn't very, it's not well written at all. It's done by mobile phone, and the people who watch those sorts of programs are highly literate, and it's a fairly lowbrow program. But he's applying sentiment analysis to that, and it's a very different type of classifier than the one that we've been using, say, for book reviews or even product reviews. And he has absolutely to train on that sort of data. Otherwise, the results are very, very poor.
So thank you very much for your presentation, and my question is about supervised learning. So you're using only the small data set for training your classifiers, the same data set which you use for unsupervised training, yes?
Yes, that's right, yes.
So, and this is the reason of low results of supervised learning, because in literature it's the point that supervised algorithms works regularly better.
Yes, supervised, they do need a lot of data, but the usual thing that people point out is that unsupervised techniques need even more data because you don't have the information from the manual annotations. So that's one thing that sort of encouraged us that we were doing comparably to supervised machine learning with the same amount of data. That's a good question.
Thank you very much.
Since you mentioned tweets, so we tried the bootstrapping these tweets, and the same approach that John tried with the emoticons. And the problem that occurs is, so when you look at the word good, then you have cartoons like good morning and good night, and then you have the words like night and morning and positive polarity. I don't know if you have looked into it and if you have any thoughts on how to do it.
I think, yes, my initial thought is n-grams, so my colleague is using n-grams, not just u-grams. And if you use y-grams, then good morning, hopefully you wouldn't get any sort of positive or negative score. You also have to, one thing that is lurking right in the background here, and I thought someone might have pointed out, is that Rust isn't a term which, or a word which denotes emotion at all. So Rust is quite bad if you get it on your kitchen appliance, and that's probably a negative review. But Rust doesn't actually have any sentiment attached to it. It's just an objective word, either it's prosody or it's not. It's not as if we're saying, I love this, and love does have an emotive dimension to it. So phrases like good morning are difficult because they usually are associated with positive affective states. So you don't normally say good morning if you're feeling in a very bad mood. But I mean, in of itself, it doesn't actually, it shouldn't really have any affective component to it at all. So there's all this sort of stuff lurking underneath the surface, which it would be great if some linguists could tell us really what to do with these words and maybe there's a good theory of the difference between rust and love and good morning, but I don't really know.
The scale of good and evil, or this positive and negative polarity is the only concept which would make sense for this analysis. I just suppose that maybe some other concepts suggest that normal versus normal or rare and frequent or possible and impossible could also make some sense for the sentiment analysis.
Yes, there are certainly other dimensions. So one example of that is political thought. So are more people right-wing or left-wing at the moment? And that's to do with opinions, but the classification absolutely isn't positive or negative. It's right and left. And there are all sorts of tasks there which are very important and very interesting to do with opinion. And you're absolutely right, it's not all positive and negative. That's just the easiest thing to do. And that's where the nice data sets are at the moment. But it would be really nice to be able to branch out and do more interesting things, as you said.
So maybe you will need some help from our linguistic audience. We are doing just these calculations.
Yes, I think it would be really great to have input, more input from linguists. But I don't think vocabularies are the way to go, because once you change the domain, then the vocabulary changes, and the meaning of individual words with respect to sentiment changes as well. So I think it would be good to have an underlying theory which is applicable to all sorts of vocabulary rather than just creating vocabulary lists.